Good morning, one and all. Almost many students are here. So what we are going to see today is we are going to see some special numerical. So this is the third session in signal flow graph. Now, first day we had seen the basic introduction and we had seen some basic numerical. Yesterday we have seen some little more difficult numerical, and today we are going to see some numerical which will really tell you that how complex the numerical can be. So I have not taken very big sized numerical, very big sized numerical. Sometimes they are very easy. Okay. So what I have taken is I have taken some typical numerical which looks very small, but their answer is very big. So sometime we will find that the denominator will become very big. So generally the numerical where the denominator is very big, they are comparatively easy numericals, because in that case it is generally found that there are many loops and there are many non-touching loops and all. But the case where the numerator is big, that is more difficult, because number of numerator is big means number of forward paths are more. Whenever number of forward paths are more, delta k calculation becomes more difficult. So I thought of starting with that kind of a numerical. I'm having total 5 numericals with me today. So I will start with the easy numerical comparatively, and then I'll go for the biggest numerical or most difficult numerical, which will be our second numerical today. So plan is to do 5 numericals, and all these 5 numericals are my handwritten. It will be uploaded just after the session. So by today evening, all these 5 numericals you should be able to understand thoroughly. If anybody is having any doubt, please ask me. So let me launch my handwritten pages. So first numerical, just for conditioning, easy numerical we will see, but real understanding will start from the numerical number 2. So let me launch my pages. Okay, so I have launched my page. This is a comparatively easy numerical which you will find all on my handwritten. So be little careful. If it is not visible perfectly, please let me know. I think it is readable. Okay, so any of you, just if you can confirm that you are able to view it and it is easily readable, then I can start. The question is always the same. That find Dia, thank you. So question is same. So all this notes I'll be uploading. So okay, I'm sorry that the video link and the notes for lab number 4, that is yet to be uploaded. So today I will do some more video recording, some small video recording for 10-15 minutes for experiment number 4, and I'll clear cut set a guideline for you. So today the experiment number 4 guideline, what to write and how much to write. It is not big, maximum 4 to 5 pages you have to write, and some 10 to 12 times you have to do that small finding the inverse impulse response, and find the inverse Laplace transform, and finding the plot. So for around 10-12 different pole position cases you have to do that. So it is not a difficult experiment, we have seen that already. So that thing will be uploaded today, and you won't have to submit it by next Monday. I will give you 1 week's time. So by next Tuesday, Wednesday, you can submit experiment number 4. Okay, so that guideline will be uploaded today, and whatever you are doing now, this notes also will be uploaded today. So I think you can visualize this thing. So this is the first numerical. I told you that today's second numerical is going to be more complex. Complex does not mean big, it is small, only 1 page numerical only. But this numerical also is the same line. So this numerical also is going to give you some understanding about the difficulty level. So how many forward paths you can see? So there are 2 forward paths. So I'm not wasting any more time for more explanation. I'll be just showing you what it is. So forward path is, so this is G1, G2, G3, G4. This is the first forward path. And I'm telling you, don't write like this because this was written last year. So that's why I have not mentioned the steps. But yes, all the steps should be mentioned. So for us, step 1 is finding the forward path. So here first you write down step 1 and then you write forward path. So that steps should be written. So by 5th step is going to be our delta or determinant, and 6th step is going to be delta k. 7th step or last step is finding CS by RS. So that is the easiest step, finding CS by RS. But the step 1, 2, 3, 4, 5, 6, they are requiring some understanding. Okay, so step one, forward path G1, G2, G3, G4. So you're finding G1, G2, G3, G4. This is the forward path. And two things I will tell you again, that is students are confusing. Number one, what is meant by non-touching loop? Okay, so in this case you are finding that this is one loop. Okay, so let me first tell you the forward path. So G1, G2, G3, G4 is the first forward path, and there is another forward path, that is second forward path. You can check here. This is G1, and then it is coming to G5. Okay, so G1, G5, and then there is G8 and G4. Okay, so G1, G5, G8, G4, they are the second forward path. So whenever some numerical is solved, you find it very easy. So when you are visualizing it, you find it very easy. But the same numerical, when you go on solving, you might miss one or two paths. Okay, so I had given you course activity one, and many people have submitted it. Around 20 people have submitted or not submitted. This one will not be assessed. I'm sorry to say that. Even if you are late by 1 minute or 2 minutes, it will not be assessed. So whenever I am uploading some kind of course activity, the solution is also uploaded. So whoever has not submitted, whoever has submitted late, you please go through the solution for course activity 1. You will understand what mistakes you have made. And those who have got less marks, less than 10, they also check what mistakes you have made. So just condition yourself. Don't worry about marks and all you have got. Try to submit all the course activity within time. Just give an attempt. This is just to encourage you, just to let you know how to go for it. Okay, so don't worry much about marks and all. So just complete your work. That's it.
Sir,
So whenever you see the solution, yep.
sir,
Anybody any doubt?
I had submitted numerical one, sir. Is that okay, or we need to submit both?
Second also you have to submit. One is gone. Okay, now you have to submit two only. So those who had submitted one or submitted late and all, they no need to submit it again. So you are submitting before time, it's okay. If you are not submitting before time, forget it. Go for the next one. Okay, so now today before 6 p.m. you submit the second one. Those who have missed first one, let it be. No problem. So the second path is G1, G5, G8 and G4. Okay, so this is the second path. Now finding P1 and P2 is easy. Finding loops are easy. Finding the non-touching loops are also easy. So where students are finding problem is finding the delta K. So next what we are going to find is what are the single loops. So G1, G2, G9. Okay, so G1, G2, G9. So this is, so G9 arrow is from right to left. So G9 is a feedback path. This arrow I have hand drawn. Okay, so this is not looking like an arrow, but G9 is a feedback path. Now don't worry if a feedback path is not mentioned as H. So G9 I can give you just a figure also. I can give you G9 is equal to 10. Okay, so I can give you. In that case you have to write loop gain as 10 into G1 into G2. So don't worry about the names. G can be forward path, H can be forward path, G can be reverse path. Does not, there is nothing in the name. Symbol you have to care for. In sometimes you will be finding that this is reverse path and here a negative symbol is there. Okay, so instead of minus G9, sometimes they might give G9 and here they might give a symbol. Okay, so you should be flexible enough to understand and incorporate it in the numerical accordingly. So here there is no symbol, nothing. G9, so this is the first loop, G1, G2, G9. Then G3, G4, G10 here. Okay, so G3, G4, G10. This is another loop. Now this first loop and this is second loop, whether they are touching or not touching. Understand is they are touching. Okay, because the first loop is having three nodes. Here you are finding three nodes. Second loop is also having three nodes, and this central node is common for both loop 1 and loop 2. Hence these two loops are touching loops. Okay, so whenever we are calculating the multiplication of two non-touching loops, we cannot consider these two. But you are finding that this loop and there is another loop G7. So this is called self loop. What is the definition of self loop? When they're starting one at one point and again coming back to the same point, it is called as a self loop. And there is only one node with the self loop, that is this one. So what we are finding is this loop 1 or G1, G2, G9 and G7, they are not touching because they are not sharing any common node. So you can say now, sir, this path is touching. It doesn't matter. If path is touching, nothing happens. Still they are not touching. As long as they are not sharing a node, two loops are non-touching. Same way, path. Okay, so this path, forward path G1, G2, G3, G4, this is non-touching to G7. So whenever you are trying to find the delta for this forward path G1, G2, G3, G4, then 1 minus G7 will come. And what is the again the definition of path and loop? They are non-touching. Again the same thing. Whatever nodes are there in a path and whatever nodes a loop is having, if they are not shared by path and the loop, then it is called as a non-touching loop. So how many nodes are there in the forward path? So this three nodes and this two. So these five nodes are combining these five nodes. We are finding the forward path, and this loop is having this node. Okay, so though this path G8 is touching this loop and this node, but then also I will say that this forward path and this loop, they are non-touching. So always the definition of non-touching. So non-touching between two loops, non-touching between one path and one loop. So what is the definition of non-touching? Put it in your head. Non-touching means they are not sharing a common node. Then I can say that these two things are non-touching. So the far path one G1, G2, G3, G4, they are having these nodes, and this loop G7, this is having this node. So this 5 6 nodes and this node, they are not touched. So in that case I can say that path and loop, they are non-touching. So this is the concept I wanted to tell you. That's why this numerical is given. So first loop is G1, G2, G9. This is the first loop. Second loop is G3, G4, G10. And these two loops are sharing one node. That's why these two loops are called as touching loops. Whereas there is another loop G5, G6. You are finding this. So G5, G6 is another loop. And another loop is G7. So G7 is another loop. There is another very big loop that you cannot see. So I will show it to you now. That is G1. So it is starting this thing. So this is the fifth thing where students are making mistake. They are not able to see this very big loop. What is that? G1, then you go here G5, then you come here G8, then G4, then G10, and then G9, and then G1. Okay, so G1, this is the starting point, left side of G1, this is the first starting point, G1, G5, G8, G4, G10, G9. So this is the another loop. So generally in this numerical where students make mistake is they are not able to visualize or find out this very big loop. Okay, so there are 5 loops. I think initially I had said 4, that was wrong. So there are mainly 5 loops which are like this. So G1, G2, G9 first loop, G3, G4, G10 second loop, G5, G6 third loop, G7 fourth loop, and G1, G5, G8, G4, G10 and G9. This is called as the fifth loop. And in loop also one point should not be repeated. So this is the starting point and this is the end point. It should not be touching the same point twice. So while finding the forward path and when finding the loop, same point. So in loop, starting point and end point same. That is the only thing. But in between, one point should not be touched twice. So these are some of the theoretical knowledge, basic knowledge. There are mainly 3. The first thing is whenever two loops they are not sharing a node, they are called as non-touching loop. Whenever a path and a loop they are not sharing any node, they are called as non-touching. And third thing is whenever you are defining a loop, the same point, only the starting point should be the end point. Apart from that starting point and end point same, no other nodes should be touched twice. Now two non-touching loops. So how many pairs of non-touching loop is there? So very easily you can find out that this loop G1, G2, G9 and G7. Okay, so they are non-touching. So G1, G2, G9, G7, multiplication of G1, G2, G9 into G7. This is the first combination. Second combination is G3, G4, G10. So G3, G4, G10 into G7. This is another combination. G3, G4, G10 into G7. Okay, this is another combination. Third combination is this G5, G6. They are having these two nodes, this one and this one. And G3, G4, G10. They are having these 3 nodes. Okay, so this loop G3, G4, G10. They are having one loop, 3 points, and G5, G6. They are having 2 points. So this G5, G6 and G3, G4, G10. These two loops they are not touching each other. So multiply that. So G5, G6, G3, G4, G10. Done. So we are, and there are no combination of 3 loops non-touching. It is not there, though there are 5 loops, but maximum you are finding 2 loops non-touching. So forward path G1, G2, G3, G4 does not touch G7. This is one more thing you are finding. That is while finding delta K. So here there are 2 forward paths. You are finding that this is one path G1, G2, G3, G4. It is touching all the other 4 loops, but this is not touching this loop as G7. That means whenever you are writing G1, G2, G3, G4 multiplied by 1 minus G7. Whatever rule I have shown you previously, that how to find delta K, you have to first write the equation of delta, and in that case you have to make all those loops is equal to 0, which are being touched by a certain forward path. Okay, so that is the mathematical rule. In If you are good enough, if you have practiced enough, so directly you will see that this G1, G2, G3, G4 is touching all the loops. So this loop, this loop, and the fifth loop all are touched by this forward path. Only G7 is not touched by the forward path. So that's why 1 minus G7 it has come in the as a delta K for the P1. So this is P1 delta 1 plus second path is G1, G5, G8, G4, G10, G9. So this is touching actually all the loops. So whenever a forward path is touching all the loops existing in the system, so in that case delta K will be equal to 1. So you are finding that G1, G5, uh, then G8, G4, like this. So G1, G5, G8, and G4. Okay, so this is another forward path. We have written it here like this. So this is a numerical. So this is a numerical which is denominator heavy. So in this case, all the denominators will come. So 1 minus. Okay. So everything is positive. There is no negative term here. Everything is positive. Even feedbacks are also positive. So that's why everywhere there will come negative sign in the denominator. So 1 minus G1, G2, G9 minus G3, G4, G10 minus G7 minus G4, G5 minus this big loop, that is G1, G5, G8, G4, G10, G9. So in this, the top line, everything is minus. So there are 5 loops and all loops are having positive feedback. That's why they are all negative. Okay, so this is the first line plus 2 loops which are not touching. So that is the first one, G1, G2, G9, G7. So it has come here, G1, G2, G9, G7. Second, G3, G4, G10, G7. Second one is this, G3, G4, G10, G7. And third one is this, G4, G5 into G3, G4, G10. So G5 into G6 into G3, G4, G10. So these are the terms. So there are total 9 terms in the denominator. 1 minus of individual loop plus multiplication of 2 non-touching loops. So such 3 combinations we get 2 non-touching loop. So that's why these 3 terms are positive. First term is at default 1 and other terms are negative. And lastly, we have written delta 1 is equal to 1 minus G7. That means in this equation, only this G7 part, that is loop 3 or loop 4, whatever thing I write, that thing is going to exist. Baki all L1, L2, L3, L5 all are going to be 0. So here you could write L1 is equal to this, L2 is equal to this, L3, L4, L5. So that is the way we solve numerical. So solve numerical that way only. So afterwards, whatever numerical I show next, it will be shown in that way. So follow that method. So that is a formal way of writing. So I think there is no doubt in this numerical, though it looks complex, but it is only observation you have to do. Okay, so now I'll go for the most difficult numerical, or most innovative numerical, you can say, for today. Let us see. This is not the one. This is the one. Okay, so remember this numerical, as long as you are doing control systems, this numerical is most special. So I have written here, this numerical is most special. It looks also special. It looks like a candle diya. Okay, and it is very special. And it is numerator heavy. Because you are finding that in the small numerical, there are 5 forward paths. Okay, and there is a huge thing that you are finding, that this is a forward path which is not touching any of the loops. You will be finding this is a forward path which is having gain of G4. Okay, this is not touching any of the loop. That means all the loops will come in the numerator as delta. So this is given as P2. Okay, so biggest thing we will understand in this case is, we will find this G4 will be multiplied by delta, because this G4 is not touching any loop. So there are 3 loops you are finding, and 2 loops are not touching to themselves, and these 2 loops are not touching to this G4 as well. So this is the first time you are finding a case where you will be finding that in delta there will be coming the terms 1 minus loop gains plus of multiplication of non-touching loop gains. Okay, So all those things. So this is a very special numerical. It's solved in one page. You will find what it is. Okay, so P1 is G1, G2. So this is the first thing. P1 is G1, G2. So there are 5 forward paths. This P1 is G1, G2. What is P2? P2 is G4. So this is the path below path. P2 is G4 like this. P3 is G7, G8. P3 is G7, G8. There's a fourth thing. Third thing. Fourth thing is P4. That is G1. Okay, G1 it is coming here. Then G5 and then G8. This is the fourth path. G1, G5, G8. Okay, and P5 path. This is G7, G6, and G2. Okay, this is G2. थोड़ा अजीब सा दिखता है, but this is G2. So G7, G6, G2. Okay, so these are the 5 forward paths. So whenever there are number of forward paths are more, in that case we have to find delta k also. Number of delta k calculation will be more. So I'll tell you the 5 forward paths. G1, G2 is first one, G4 is the second one, and here calculation of delta K for G4, that will be the biggest job. That means delta 2 will be the most difficult thing. Then is third path G7, G8. There's a third path. Fourth path is G1, G5, G8. So this is G1. Then this, sorry, this is G1. Then this is G5. Then this is G8. And last path is G7, G6, and G2. Okay. So number of individual loops, there are 3. So first you are finding L1 is equal to G9. This is called as a self loop. L2 is equal to G3. This is called another self loop. Self loop means starting point, end point, they are same. G3 is L3 is G5, G6. So G5, G6 is L3. If anybody is having a doubt, please raise hand. Please ask me the question. No problem. Step 3. Do we have two non-touching loops? We have, because this G3 and G9 they are non-touching. Okay, so one pair of non-touching loop, that is L1 into L2, that is G3, G9. Three non-touching loop, not sorry, three pair. Three non-touching loops are not there because maximum loop are 3 only. And if you are saying this 3 loop, there can be cases there are 3 loops which are not touching each other, but in this case that thing is not there. Yes, 2 loops non-touching are there because this first loop is having a node as this one, top one. Second loop is having node as the bottom one, and this node they are not shared. Hence, G9 and G3 they are multiplied L1. Okay, so write down what is delta. So 1 minus 3 loops. Okay, so G3, G9, G5, G6, and there is plus 2 non-touching loop multiplication. That is G3, G9. So what is delta? Delta is 1 minus G3 minus G9 minus G5, G6 plus G3, G9. So finding delta is very easy in this case. Now we have to find out delta 1, delta 2, delta 3, delta 4, and delta 5. So first step, delta is found. Now first thing, delta 1. Okay, so what is the path? G1, G2. You are finding G1, G2. So G1, G2 is touching this G5, G6 loop as well as this G3 loop. Okay, so how can we find delta 1? It will be 1 minus G9. So now you have to go very fast. So there are 2 ways of finding delta. One is directly by observation. You can find out 1 minus G9 directly because this is a forward path. There are 3 loops. 2 loops are touched by this forward path because see that this node is common for this forward path and this loop. This node is common for this forward path and below loop. But this for top G9 and G1, G2, they are not sharing any node. You can say they are touched by G5, correct, or G6, correct, but they are not sharing any node. So this is a definition of non-touchingness. So non-touchingness does not mean that they are not connected. They might be connected, but they are not sharing any node. This is a very big definition of non-touching. Either you say loops or you say path and a loop. So non-touching means not sharing any node. So hence, you could find delta 1 by substituting. So this central loop is called loop 3. This below loop is called as loop 2. Okay, so loop 2 and loop 3 are touched by G1, G2. So in delta, you substitute all the L2 and L3 as 0. So that means only L1 remains. And what is L1? That is G9. That's why delta 1 is 1 minus G9. Either you do it mathematically, that is in delta, substitute all the loops, touching loops touched by this forward path as equal to 0. and only leave that much part non-zero which is not touched by, which loop gain is not touched by the forward path. So that is the way doing it. That means L2 is equal to L3 is equal to 0 in delta. If you substitute, you will find that only 1 minus L1 will remain. Okay, and L1 is equal to G9. So 1 minus G9. I don't think there is any problem here. Biggest thing for which this numerical is designed, so this is said this is a very special numerical, this is a most special numerical because of this line now which I'm going to explain to you. That is delta 2 is equal to delta for the loops which are touched by this path. Okay, so but this path is not touching any of the loops. Okay, so delta, and there is no zero, that means the whole delta will come as delta 2. And in whole delta, what you are finding? Whole delta you are finding 1 minus G3 and G9, it will come 1 minus G3. So G3 is not touched by this forward path, that's why it is coming in delta K, that is delta 2. G9 is not touched by this forward path, that's why it is coming in delta K, that is delta 2 minus G9. G5, G6 is not touched by this path, that's why minus G5, G6 is coming here. Plus, now this G3 and G9, okay, so loop 1 and loop 2, they are non-touching and they are not touching this G4 also. So this part is also coming in the delta K calculation, in delta calculation. So this is the first time we are finding that two non-touching loops, they are not touching a path as well. And this is the first time we are finding it. Generally what we used to find is 1 minus only the loop gain, because that loop is not touched by this path. So generally we used to find 1 minus G3, G9, G5, G6, all those things. But here this G3 and G9, they are not touched by this forward path G4, and they are not touching each other as well. That means this whole denominator, that means 1 minus G3 minus G9 minus G5 G6, yahan tak to theek tha, plus G3 G9, that is exactly the way you calculate the denominator, exactly the same way only you have to calculate delta K as well. Only thing is you have to say is while calculating delta K, if the forward path is not touching any loop, only those things you have to consider, and whichever loops are touched by the forward path, those things you have to make equal to 0. So this is the most important line, how to find delta 2. So while finding delta 2, you have to say that this forward path is not touching any of the loops, and denominator is calculated only by loops, they are touching, non-touching, how many pairs are there which are non-touching, how many combination of 3 loops are there which are non-touching. So the whole numerator you will, sorry, whole denominator you will find will be as delta 2. The question, the logic being, this G4 is not touching any of the loops. So 1 minus G3 minus G9 minus G5 G6 plus G3 into G9. So this term is very new and you did not have idea about this term. So exactly the way you calculate denominator, the same way you have to calculate delta K as well. And only you have to see that the path, forward path is not touching those loops. So very important thing, this delta 2 concept, please understand this. So as G4 does not touch any of the loops, so whatever are the loop properties, so 1 minus single loop plus multiplication of pairs minus multiplication of all 3, so all these things will come. So after this we will take another numerical where we will find that there are 3 loops, they are non-touching among each other and they are not touched by a forward path. So all those things will come in the denominator, in the numerator as delta. So that numerical we will see. So this delta 2. So this is special numerical because delta 2 in this case is very different because G4 is not touching any of the loops. Now delta 3. What is delta 3? So delta 3 is nothing but related to P3. So this is G7, G8. You are finding that G7, G8 is touching this G9 as well as G4, G5. So this G7, G8 when they are coming at the numerator, it will be 1 minus G3. So this is 1 minus G3 because delta, whenever you are calculating this L1 and L2 has to be made 0. That means only L2 will exist. And what is L2? It is G3. So it is 1 minus G3. So the third loop, that is P3, sorry, third path, that is P3, G7, G8, it will be multiplied by 1 minus G3. Now the remaining 2 forward paths, what you're finding is P4 and P5. Okay, so P4 you're finding there's a P4, G7, G6, and G2. Okay, so this is touching this node as well as this node. So P4 is touching all the loops. So delta will be 1. And P5 is, you can say this is G1, G5, and G8. So G1, G5, and G8. So P4 and P5, they are touching actually both these nodes. That means P4 and P5, they are touching all the loops. So in that case, for P4 and P5, delta will be equal to 1. So whenever we are finding that if some loops are touching all the paths, in that case, for their case, delta is equal to 1. That means for the first path, there is a 1 minus G9. For the second path, the whole delta is coming getting multiplied with G4 because G4 is not touching any of the loops. For P3, 1 minus G3 is coming. For P4 and P5, only 1 is coming because P4 and P5 is touching all the loops. Now the finally transfer function, this you have to understand. So CS by RS, so this is the first path which is 1 minus G9 because the first loop is not touched by G1, G2. Second, G4, so this is the most important part which students will make mistake. So you can see that exactly this path is same as exactly the denominator. So this part and denominator is same because G4 is not touching any of the loops and there are two loops which are not touching to each other as well. So this is the most important part in the numerator. Plus G7, G8, G7, G8 you can find here at the top that G7, G8 is not touching this G3. That's why it is coming as G7, G8 multiplied by 1 minus G3 likewise. And then you are finding the fourth path and fifth path. So this is actually the numerator. Jagah thoda zyada lagta hai, isliye I have written to the top. You can write below to this also, but not below the line. Okay, so likewise, you should understand how many things you have to write, and accordingly you have to make space. And denominator is easy. So denominator already we have found. So this is a numerator heavy numerical you are finding here because there are 5 paths. The 5 times you have to calculate delta k, and that process is cumbersome. So this is a very important numerical. Please prepare this. Now here is coming big numerical, and this is only big in size, but this is not big in fundamentals. Okay, so let us see. And after this, whatever numerical I do, this is in the same shadow of this, and it's so big, the result is so big that I could not write the answer in G and H. I have written the answer in L. That is another way of doing it, but in exam such big numerical will not be asked. Okay, be careful, but if it is asked, you can leave the answer in L, but generally we don't expect the answer in L, we expect the answer in G and H only. So let us understand these two numerical. Next one is in shadow of this. So here we are finding there are 2 forward paths. So G1, G2, G3 is the first forward path, P1, and exactly this is the way you should write the numerical. Previous numerical also, if you see, I have written all this, step 1, step 2, step 3, and all this. So this is the way you should represent the numericals, this one. So number of forward paths, K is equal to, I'm sorry, I have made a mistake. So number of forward paths, K should be equal to 2. I'm sorry. So there should be K is equal to 2. So P1 is equal to G1, G2, G3. This is the first forward path. And second forward path is G4, G5, G6, like this. Okay, so there are 2 forward paths. This K should be equal to 2. I will correct it before uploading. Individual feedback loops. So you can find there are 4 feedback loops, or there are 4 loops. So this is the first one. L1 is minus G1, H1. L2 is minus G2, H2. L3 is minus G3, H3. And L4 is minus G5, H4. Be careful. Okay. Sometimes you directly write it G4 H4. G4 is here. Okay, so minus G5 H4. So we want you to make mistake. That's why we set this kind of trap for you. So G1 H1, G2 H2, G3 H3 all are negative. G5 H4 is also negative. So what you will find in the denominator is there is no negative term. This is a very important thing. Okay, because all feedbacks are negative feedbacks. That means there should not be any negative term in the denominator. So be careful about that. So these are the 4 paths like this. Now, how many pair of non-touching loops are there? First, let us see this one. So this is L1, L4. That means this one and the top one. Okay, so this is a pair, L1 and L4. Okay. Now, second one is L4 and L2, like this. So these 2 are non-touching loops. Why this L1 and L4 are non-touching? They are touched by this path. It's okay. So it is not about the path, it is about the nodes. L1 is having these 2 nodes, and L4 having these two nodes. So L1 and L4, loop 1 and loop 4, they are not sharing any nodes. That's why they are called as non-touching. Whereas this G1 and G2, so loop 1 and loop 2, they are touching this node, they are touching. Okay, this and this, they are also sharing this node, hence they are called as touching. L1 and L3, they are not sharing any node, you can say. Okay, so here there are these two nodes, and here also there are these two nodes. Okay, hence L1 and L3, they are not touching loops. So I have written here, you can check L1, L3. So this is the L1, L3. Okay, so this is a pair of non-touching loop. So top L4, L1, this is one pair. L1, L4, L2 is written here. L4, L3, this is the third one, and L1, L3. So these are four non-touching loops. Hence, it will all come in the denominator. So what we have found is there are four loops, and there are four combinations of pair of non-touching loops. And then you are finding, this is the first time you are saying that if there are three loops which are non-touching. So here you are finding this fourth, first and third. So you are finding that L1, L3, L4, they are actually non-touching. So L1, L3, L4, they are non-touching. So it is written here, so I will just reduce the size a bit. So in that case, you will be able to see everything in the same page. Is it visible? I have made it smaller a little bit. Is it visible? Can you read this?
It's okay, sir.
Okay, it's okay. Thank you. Okay, because I want to show you the whole thing. And the question I will cut. Okay, so I will show you the whole page. So now, what we are finding is there is one combination of three non-touching loops. That is this fourth, first, and third. They are non-touching. So L1, L3, L4. Now you write down step 5. So step 5 is 1 minus. So 1 minus, this is L1, L2, L3, L4. All these things I have written plus. ये plus जो है ये formula का plus है. Okay, so plus this four thing L1, L4, L2, L4, L3, L4, and L1, L3, like this L1, L3, L1, L4, L2, L4, and L3, L4. So L4, L1, L4, L2, L4, L3, they are understandable, but this L1, L3, this you don't miss. Generally people make mistake here. So every numerical I'm telling you where the students are going wrong, be careful. Okay, so like this, and minus of L1, L3, L4. So L1, L3, L4, this is another new thing. So every numerical I'm giving you different. Whatever numerical I'm giving for course activity, that also you should add in this list. Okay, so they are also different in every aspect. Now, the most important step is finding delta 1 and delta 2. So there are two forward paths, G1, G2, G3. So G1, G2, G3, this is the path. Okay, and what will be the delta 1? It will be 1 minus of L4. So directly you are finding delta 1, finding P1 is touching L1, L2, L3. Okay, so P1, the forward path 1 is touching L1, L2, L3, but P1 is not touching L4. So in this whole equation of delta, wherever L1, L2, L3 is there, make it 0. Okay, so this whole term will become 0. So pairs, because everywhere either L1 or L2 or L3 is there. So L4 is there in three terms, but L2, L3, L1 all are equal to 0. So everything will, pair term will become 0. Cube term, that is 3 loop term, will become 0. And in this case, L1, L2, L3 will become 0 because the forward path is touching all the loops. But this forward path is not touching this top loop. So only what will prevail is 1 minus L4, and L4 is G5H4. So delta 1 will be 1 plus G5H4. This much you have to understand. So the top part, that is whenever you are calculating the delta 1 for forward path 1, in that case only it will be 1 plus G5H4. So that term will prevail, 1 plus G5H4, because L4 is minus G5H4. And second case, that is if you are checking this path, that is G4, G5, G6 and all, this is the forward path 2. In that case, it is touching this L4. So in this whole combination, you have to substitute everywhere L4 term is equal to 0. So how many terms are there? Here 4, here 4, 8, 9, that is 1, and this is 10. So there are 10 terms. In that case, you are finding that here this term will go to 0, and here 3 terms will go to 0, and this term will go to 0. One very important thing, L1, L3, it will prevail. Okay, so whenever this part is there, okay, that is G4, G5, G6, it will be multiplied by 1 minus of G5H4, that means 1 plus G5H4, plus G1H1 and G3H3. they are loops. Okay, so this one also will come. So whenever you are finding, and you are finding finally that this loop and this loop, G1 and G3, this loop, that is G1H1 and G3H3, they are not touched by the top path, as well as they are non-touching to each other. So this term also will come in case of this loop. So let us see what all things are there. Okay, so 1 minus L2 minus L3, that means 1 minus this and this. Why these terms won't come? Why this H1 G1 will not come? Because this path, if you see, this path is going up, this path is going up, and this path is touching this H1 G1. So whatever I was telling is, don't make mistake. So some people might think that this G1 H1 and multiplied by G3 H3 will come at delta 2. It will not, because this G1 H1 is actually touched by the forward path 2. Okay, hence this thing is not having any bearing on forward path 2 in delta 2. So only what will come in delta 2 is, in this equation, wherever L4 is there, you make it equal to 0. So what prevails is 1 minus, and sorry, L1 also you have to make 0. I'm sorry, I missed that. L1 also you have to make 0, because L1 is also touched by this P2. So L1 you have to make 0, and L4 you have to make 0. So what remains is only L2 and L3 term. So 1 minus L2 minus L3, and here everywhere you are finding, so L1 L3 it will become 0 because L1 is 0, L1 L4 0, L2 L4 0 because L4 is 0, L3 L4 is 0 because L4 is 0. So only what will remain is 1 minus L2 minus L3. So I made a mistake, I'm sorry. This path, that is forward path 2, it is touching both L1 and L4. So it is not only L4 but L1 is also touched by forward path, because this node A, okay, this is I have written, node A is common in loop 1 and P2. So this is loop 1 and this is path 2. So what is common between them? This node is common to that. That means this loop 1 also will not come in delta 2. Loop 4 will not come in delta 2 because these two nodes are common between the forward path and the loop. Okay, so only what will prevail is L2 and L3. So delta 2 is equal to 1 minus L2 minus L3. Now this part writing, is not deducts. Only you have to see what is L1, what is L2, what is L3, and their combination. So these two things, it looks big, but actual game is there in the previous page. Okay, so actual game is there here, and the biggest part is there in finding delta 1 and delta 2. Okay, so check this numerical also, and you'll be finding what new in this. So what new in this is, we're finding that delta 1 and delta 2 is a little more critical than the previous numericals. Now what I'm telling you is, look at this numerical, and next numerical I will show, which looks little different than this. It looks similar, but it is not same, and that's a very big numerical. So look at this, and now I'll go to the next page and I'll show you what is the next thing. So it looks kind of same, but it is not same. So what are the differences? Here you are finding that all the loops. So this is the first thing, very important, because it's very big answer. It is not difficult, but many cases are there. So biggest CSRS so far. Okay, the numerical which I had shown here, you like this numerical. This was having very big numerator. Denominator was small. Okay, this is a numerical where you are finding that yes, there are 4 loops, and the 3 non-touching loop concept has come here for the first time. You are saying, okay, and there are many combinations, delta 1, delta 2 you are finding and all. Okay, likewise, but here what you are finding is, it is the mother of all numericals. It's very big. Okay, because you are finding that all 4 loops, they are non-touching to each other. So this is the first time you will be seeing the combination of single loop, pair of non-touching loops, combination of 3 loops which are non-touching, and combination of 4 loops which are non-touching. So there will come the term as L1, L2, L3, L4. Okay, so this is for the first time you are seeing all the loops, they are non-touching. And it's about a numerical. I'm not going to design. So this numerical will not get any book. So this is I have designed just to show you, and answer is also given, and you just go step by step, you'll understand everything. It is not difficult, same fundamental repeated. I have just made it big just to give you the case up to 4 non-touching loops, how to represent it. What are the One more thing in this case, what I have done is this loops I have kept as G1, H1, G2, H2, G3, H3. This is G4, H4. All are P2, and this gains I have mentioned as some integer number. Okay, so there are two forward paths. Same thing. This is the first forward path. So 4G1 into S7 into G2 into 3 into G3. So some numericals, even I will substitute G1, H1 as some number that I can do. In that case, directly you'll be finding CS by RS as some figure, maybe 39 or 67 or something. So that is possible. So just to give you a feel that instead of G1, H1, I can give you any ABC I can give, some integer, some float I can give, it doesn't matter. So don't get confused with that. So P1 is 4 into G1 into 7 into G2 into 3 into G3. That is what. P2 is 2 into 5 into G4 into 3 into 1. So this is 30 G4, that is P2. P1 is 84 G1, G2, G3. And now you have to understand, because I will go to the other page, just understand. So how many combinations of pair non-touching loop? So we are having four things. So there are four loops, you know. What is that? L1, L2, L3, L4. So that is what. Now those who play cricket, they know if there are 8 teams, okay, how many combinations will be there if they play with each other. How do we find that? If there are 8 teams, all team play with each other. How many combinations? So it is found by 18 divided by 2. That is 56 by 2. That means there are, so NC2, NP2, whatever is there, it is 8 into 7 divided by 2. That means there will be 28 matches. Likewise. So in this case, there are 4 loops. Okay, and each loop is non-touching to each one. So how many combination will be there? So this is 4 into 3 divided by 2. That means there will be 6 combination. That is L1, L2, L1, L3, L1, L4. Then L2, L3, L2, L4, and last is L3, L4. I will tell you again: L1, L2, L1, L3, L1, L4. ये होगी in combination. Then L2, L3, L2, L4. 5 combination. Final is L3, L4. Okay. So there are 6 combinations. So all 4 loops are non-touching to each other. Hello, hello. Is it visible? Is it visible?
Yes, sir.
Excuse me. Hello. Anybody? Okay, because I just lost connection for some time. Okay, so now 4 loops, how many combinations you can make by 2? So this is 4 into 3 divided by 2, that means there are 6 combinations. Oh, ho gaya. How many combinations of, okay, and there are 4 non-touching loops. So this is the first time you are finding it. So it will be L1 into L2 into L3 into L4. That means G1, H1, G2, H2, G2, G4, H4. Okay, so it will come at the denominator. So 2 non-touching loops ka 6 combination. 4 non-touching loops ka ek combination. Now 3 non-touching loop. So this 3 will come. So L1, L2, L3 will be a combination. L2, L3, L4 will be another combination. L1, L2, L4 will be one combination, and L1, L3, L4 will be another combination. So there are 4 things, and you have to club 3 things together, because everything is now non-touching to each other. So what are the combination? 1, 2, 3, 2, 3, 4, 1, 2, 4, and 1, 3, 4. Okay, likewise. So in the next page, it is given. You can find out. So now what we are finding is combination of 2 non-touching loops. So there will be 4 into 3 divided by 2, that is 6. So it is given as L1, L2, L1, L3, L1, L4, L2, L3, L2, L4, and L3, L4. Likewise. Combination of 3 non-touching loops. There are 4 combinations like this. That is L1, L2, L3, L1, L2, L4, L1, L3, L4, L1, L4. There is one combination of 4 non-touching loops. That is L1, L2, L3, L4. So all these things will come at the denominator. So here I have written delta first. So 1 minus L1, L2, L3, L4 plus, here I have written the 6 things: L1, L2, L1, L3, L2, L3, L4, L1, L3, L4, minus, here are the 4 combinations of 3 non-touching loops. अभी उसका value क्या है वो साथ में देखेंगे, and you will be finding that everything will be positive, because all the feedbacks are real feedback, because each of this L is negative. So here 2 negative multiplication will become positive. Here every negative will become positive. Here also 3 terms. So each negative, that means become positive, and 4th term is multiplication of 4 negatives. It will become positive as well. So like this. And now you go for finding delta 1 and delta 2. So what we find is while finding the delta 1 and delta 2, so go to the previous page. we are finding that the first case, that is the path 1. Path 1 is actually L1, L2, L3. All these things should be equal to 0. And for path 2, L4 should be equal to 0. Because path 1, in delta, we have to substitute like this. For path 1, we are finding that path 1 is touching L1, L2, L3 and not touching L4. So for path 1, L4 should be existing and L1, L2, L3 should be substituted as 0. And for path 2, L4 will be 0 and L1, L2, L3 will be existing. So if you do that, what you'll be finding is in this equation of delta, what you do is just substitute L4 is non-zero and all other terms make it 0. So what we are finding is delta 1 is 1 minus L4. So 84 G1, G2, G3. You go to the previous page, you are finding that P1 is 84 G1, G2, G3. So that will be multiplied by 1 minus of H4 G4. In the numerator, you are going to find is 1 minus L4 multiplied by 84 G1, G2, G3. And then delta 2 we have found. So here I have substituted delta 4 0. So it is L1, L2, L3. Here, so this is a new term. New term you are finding that means multiplication of two non-touching loops. Okay, that will also come and get multiplied with P2. Okay, multiplication of three non-touching loops. Just see that whenever you are finding the delta for this path, first there will come this minus minus, then there will come plus of this two, plus of these two, then minus of all these three things. This is a very important thing which we are seeing for the first time. That is the delta. We have put exactly the way we have created delta. So delta k and delta, they are same. Only thing is L4 you have to make it 0. So whatever term remains after making L4 0, that big thing will become delta 2. So I have written CS by RS, but in exam you cannot leave it like this. You have to show all these things. You don't multiply, that is okay, but at least show every term by means of by means of G and H. You cannot leave things as L, as I have written. L, delta, all these things should not come in the final CS by RS. So it should be in terms of H and G and whatever integers are there in that form. Okay, so this is the third thing. It's a very big thing, but I have made it look small in the final thing. I think you have understood it. That's it. Now here, this is the last numerical. I think if I get some, those who are having some other lectures, you can leave, because this is a numerical. It is only one page numerical. I'll keep on explaining. I'll upload this notes to you. So now next time onwards, I'll do a recording of an extra lecture, and I will show that how to convert a block diagram into signal flow graph and solve it. So this is the next step. So more complex another thing is done. Every type of complexity is covered. Now we have to convert an actual system into signal flow graph. So generally, if I give you a circuit, from circuit you can generate block diagram, and from block diagram you can come to signal flow graph. So just see here, this is the RS, this is G1. I'm telling you, if you are having other lecture, you can just leave, give me 5 minutes. Okay, I will record and upload it. So after G1 there is coming a node. So this is a summing point, this is represented as a node, and then this is G2, and then here there is another node, and this node is given by this, and then another G3. Okay, and here be careful. So this is a node, this node is given by this, and this is another takeoff point, it is shown by this. So be very careful while converting a block diagram into a signal flow graph. So how many points are there? This is 1 point, 2 point, 3 point, and 4 point, where some new thing is getting joined or new things are removed from there or taken off from there. So that's why there should be 4 nodes. So this is the first thing you have to understand while converting a block diagram into a signal flow graph. Okay, so here in the forward path, this is the first case, this is the second node, this is the third node where things are getting joined or things are getting removed, and this is the fourth node. That's why first, second, third, fourth, these are the fourth node. From this fourth point, H1 is taken back. Okay, H1 is taken back and it is coming here. So this is also another summing point. It is shown here below like this. Okay, so from top, so from this second point to this below summing point, there is coming another thing. So that is here like this, as 1 it is coming. Okay, and from this fourth node, it is coming to this joint as H1. So from this fourth node, node, it is coming to this point as h1. It's very easy. You look at it and you'll understand. But only when you will start converting this block diagram into signal flow graph, you might have some problems. So just follow this numerical properly. So from this node to this node, there is a connection of H2, and this is minus H2. So this is another thing you have to remember. So just at this point is coming and being added. So this one is plus plus H1. This from this point top, it is coming to, it is getting additive kind of a thing. So I'm showing it as 1 plus 1. To here it is shown as plus h1, but from here this point, which is same as this point, if you are going here, it is actually negative feedback. Hence this is called as minus h2. This minus because this negative feedback. Say from here central point, 2 points are going above. This point is going to the right and getting added, so that's why this point is called as plus 1. From here this point is going back and negative, that's why this point is called as minus 1. So be very careful about symbol whenever you are converting a block diagram into a signal flow graph. Okay, so now it is given here, so I don't think there is anything difficult in this. Only thing is be careful about how many points or how many nodes are there. So in this case, you are finding this is one node, this is another node 2, this is another point 3, this is another point 3. So on the forward path, there will be 4 nodes, 1, 2, 3, and 4. And feedback path below, there is only 1 point node. And you can see that this point can be mixed. Okay, so this point is actually a junction, and this junction can be brought down. So that's what I have made this point as a node point. So from this central point, actually there are 4 things which are going out. So one is this plus 1, this is minus 1, and this is coming to be plus 1, and this is going to the right. Okay, so either you could take it up and prepare a node there, but that node and this node is actually shorted. That's what I have taken it from this point. So this another node could be created here, that will not change the result. So this is now the diagram, and now I'll make it a little big and I will give you the final answer. It is very easy actually. It's a very small numerical. Already the solution is given to you. So now when you have converted it into block, so this block is converted into the signal flow graph. Now you just find out. So number of forward paths, there are 2. So G1, G2, G3, this is the first forward path, and G1, G2, 1, this is the second forward path. So this part is G3, this is one forward path, and this G3 and is this 1, they are actually parallel paths. So first a K1 again, G1, G2, G3, this is the main forward path or main body. Second one is G1, G2. So this is G1, G2, and this is going up and connected here. This is the G1, G2. How many loops are there? So there is only one twist in this numerical, because एक अजीब सा loop है इसमें that I'll show you. So first loop is this minus G2. So this is G2 into minus 1. This is the first loop, no problem. Second loop is G2 H2. So this is G2 1 H2, and this H2 is minus because this H2 is connected to negative feedback. So this is minus G2 H2. Okay, so G2 and H2 minus is there. Third loop is G2 G3 H1 H2. So this is G2, then G3, then it is going here, then it is H1, and then it is minus H2. So G2 G3 H1 minus H2. So this is minus G2 G3 H1 H2. This is there. Last loop is G2 H1 H2. That means it is coming here and then going up. Okay, so G2 and then this 1, because this 1 and G3, they are parallel paths. Okay, so this G2, then 1, and then it is going here, then H1, and then minus H2. So I'll tell you, this SFG signal flow graph is the game of observation, nothing else. This is only the game of observation. So first one is G2 G3 H1 minus H2. This is one loop, and second one is G2 this 1, because 1 and G3, they are parallel paths, and then it is going here. It is nothing given here, means this is 1, that is this path. So G2 1 H1 and minus H2, like this. So number of 2 non-touching loops and 3 non-touching loops are not there, because everything is touching everything. So 2 non-touching loop, 3 non-touching loop are not there. So there are only 4 loops, individual loops. So what you are finding is denominator is 1 plus G2 plus G2 H2 plus G2 G3 H1 H2 plus G2 H1 H2. That means only the individual loops, they will come at the denominator. So where students make mistake in this numerical is they are not able to figure out this loop G2 1 H1 minus h2. So this is one point they are making mistake. They are falling short by one loop. This is generally what we find. And second thing a student making mistake is this h2 is given to the negative. So this h2 should be taken as minus h2. So these are the two mistakes generally we find students are making. The first mistake is g2 g3 h1 minus h2. Many people can find out if they consider this as minus h2. This is minus because this is minus. Now this h1 was minus. If the h1 was minus and h2 was also minus, in that case this is minus h1 minus h2. That means this path will be considered as a positive feedback path in that case. So that is another thing you should be careful, that h1 is coming and positive or negative, h2 is positive or negative. So whatever is the final symbol, depending on that you have to write what is the magnitude and what is the symbol of this. So h2 is the magnitude, minus is the symbol, and you have to do it accordingly. Okay, so this is very simple. So 1 plus G2 plus G2H2, G2, G3, H1H2, G2, H1H2, all these things are there. So there is no any path which are not touched by any forward path. So directly addition of two forward paths, that means delta 1 and delta 2 both are equal to 1, because each of the forward path is touching each of the loop. So there is no loop which is not touched by any forward path. So this is one line you have to add, that is both the forward paths are touching all the loops. Hence, there is delta 1 is equal to delta 2 is equal to 1. So finally, what is the transfer function? This is the addition of both the forward paths, that is g1, g2, g3 plus g1, g2, and denominator is 1 minus all the individual loop gains. So everything is positive because all the feedbacks are negative feedbacks in this case. So this is another numerical, which is the first numerical where we are converting the block into signal graph, and